Alright, this will be the first of two videos. This one, I'm going to very quickly cover some data collection and graphing basics at the higher level. And I've gone through and made up some data points to save some time. But some things that I do want to clarify is number one, you can never enter any actual data into the gray cells along the left-hand column or the top row. Those are for headers only. And if you're bothered by them and you like a nice clean data set, you can delete them. But I'm going to show you why that's completely unnecessary, because we're just going to crop a screenshot and pop it into Keynote at the end. So you put your independent variable always first, or rather the variable that you are modifying. And because I'm changing my length and seeing how the period is affected as a result, this is my cause, this is my effect. Independent variable, dependent variable. So always put your independent variable first and your dependent variable second, because that will, when you create a graph, automatically create a graph that puts your independent variable along the x-axis and your dependent variable along the y-axis. And also you should see the cause before the effect. So logically it should make sense why I'm doing this as well. So once you've collected all of your data and put units in parentheses for each of your data sets, you're going to click the first cell that's included in your data table, and you're going to click this little blue dot in the bottom right corner, and you're going to drag it over and drag it all the way down. But you're not going to stop after the last data point. You're going to include a bunch of blank cells at the bottom in case when you look at your data, you realize, oh my goodness, I can't tell which proportionality this is. I need to collect more data or stretch out my x-axis or test a larger range of lengths. So I'll show you how to do that. I'm going to highlight that, and I'm just going to go all the way down to the bottom of my table, because why not? It doesn't hurt anything to highlight blank cells. Now once you do this, you're going to click the cell actions right up here in the top, this one that I keep kind of highlighting. Click cell actions, and now I'm going to click create new chart. Now you want to make sure that you're in this 2D option at the top, not 3D, not interactive, two-dimensional. Once you're in two-dimensional graphs, 2D graphs, 1x, 1y, then you're going to come down here to this bottom option, this XY scatter plot, and click on it once, and that will automatically populate a graph. Fantastic. And you don't have to do any editing on here, but that should cover us for data table. But I do want to point out a couple of things with graphs that you should always be careful with. So now I have this graph, and I can't quite tell which proportionality this is. I can't tell if this is a linear proportionality or if it's a square root curve. It's really hard for me to tell based on the data that I'm given. And you might have the issue where you can't tell, is it a square root proportionality? If that's the case, your solution is to stretch out the x-axis, stretch out the independent variable. Take this data as far over as you possibly can. If you're testing length, cut a length of string from the ceiling to the floor. Better yet, go into the stairwell and hang a string all the way from the top of the stairs down to the bottom. But also, don't forget to collect as much data down here at the bottom too. So stretch out your x-axis as much as possible, making sure to get data points that hit the ends while also being spread out throughout the middle, so you get a good collection of data. And then you might see, hey, these data points are flattening out. It's a square root proportionality. Or maybe they are in fact curving up, making it an exponential proportionality. Or maybe it truly is straight. I can't quite tell from my data. So I'm going to put that away. And now I'm going to go back and collect more data. Fortunately, I've already made up a number for this. I'm going to use a length of 1.1 meters, which I would argue is not stretching out the x-axis far enough. You want to really stretch out your independent variable as much as possible. But when I did that, I got a time of 23 seconds. And now when I come down here, I realize, oh my goodness, that absolutely is pointing towards an exponential graph. So now, once you have collected enough data and you've created your graph, you're going to do two things. Number one, you're going to take a screenshot of each of them. I don't know how to put this away. Go away. Oh, that worked. And once you take the screenshot, you can click on the screenshot and you can click and drag the corners in so it highlights only your data. That's why we don't have to delete the blank rows. And now I have a great data table. And I'm going to save that to my photos. And then I'm going to come down here and take a screenshot of the graph. By the way, that title that you see right up here, that's not an official title. Your title should always be Y versus X, but I'll show you what I mean by that in the next slide. So I'm going to crop that auto-generated title out as well. And now I have a screenshot of my graph. Once you have a good data table and a good graph, number one, you can take your data table and plug it straight into Keynote. And this is not something I've emphasized before, but I think Keynote makes much better looking graphs than Notability. I think Notability is great for editing, great for writing, great for drawing. But once you've done the editing and the drawing in here, take another screenshot and send that into a Keynote slide. So it's extremely clean and organized, and every slide can be used for a different section of your lab. So the first slide could be your title section, the second slide could be your hypothesis section, third section would be data table, and fourth section would be graph, because this is an extremely simplified lab. All right, so you guys should be completely good on data tables, but there are a couple things I want to point out with graphs. Number one, your title should always be Y versus X. How is this affected by this? How is period affected by the color of the pendulum? So your title at the top should always be in the form of Y versus X. You should have axes titles with units in parentheses, just like you did in your data table. So color is measured in micrometers and period is measured in seconds. Next, whenever you do the trend line, don't ever connect the dots. There will be times in your life where that might be the appropriate graph, but in physics, that is never, that I can recall, the correct graph, especially when you're seeing how one variable is affected by another. And maybe I'm forgetting something, but I don't think there's any situation in physics where that applies. So don't ever connect the dots. That concludes all of data table and graph basics. That's all I'm really requiring to start with. However, in the next video that I'm going to finish right now and upload quickly, I'm going to go into more advanced graphing techniques. Or rather, how can you analyze this graph and get worthwhile information out of it? So I hope that was helpful for creating the data table and the graph, and I suppose you made it through the video, and I should reward you with a dad joke of the day. Why don't zombies care what you wear or what you look like? Because they only like you for your brains. If you made it this far, thanks for watching, everybody. Have a great night.